this is a function, and of course it goes on forever. And as you see, it goes up to a maximum, comes down to a minimum. We're going to talk about these, and then comes up to a maximum and comes down towards negative infinity. So these are, we're going to talk about them later. They're called local max, local min. In this case, they're also absolute. There is nothing higher than this. Okay, so we're trying to graph a rough estimate of f prime. Now the question is, who cares? Why would I care about this? Well, if I know when a function increases the fastest or decreases the fastest, or for example, the stock market, if you're interested in what particular, I don't know, EFT or shares or any particular stock, then you're going to look and see when is the fastest increase, when is the lowest increase, and so on and so forth. So we have a lot of applications for the derivative, and you're going to see many applications till the end of the course of the derivative. Why is this so important? But how will I come up with a graph? Well, I have to think in terms of what does it represent? This function represents the slope of the tangent line at any point. Okay then, so I'm going to go to the graph, and I realize that at these points, the tangent, the slope of the tangent and the tangent, right, the slope is 0. Because at these points, the function has a maximum. So at this point, the function, the derivative, will be 0. Why will be 0? Because the tangent is horizontal. The graph is, the line is horizontal, so the tangent and the slope is 0. So at these points, I'll come back here, because it has to be at exactly that point, that x value. And the same thing here. The function will be 0. What function? This one. Why? Because the slope of the tangent here is 0. Here's another point. Right here. The tangent is horizontal. The slope will be 0. That's easy because it's the origin. Perfect. So for now, I found 3 points that belong to the first derivative. Okay, next. I'm going to look at several points. So let's say at this point right here, I draw the tangent, and I try to form a right triangle. At that tangent, using that tangent. Does it matter if I use these 2 points or these 2 points? No, it doesn't matter. You can use this point and this point. You can use this point and this point on the same line, of course. Okay? It doesn't matter where, because the slope of this, as you go up a hill, if you go up or down, or if you use this point as the origin and this point as the origin, or any other 2 points, the slope will not change. You're still going up the same hill. If you come back, it's still the same slope. And I'm going to estimate. So I'm going to say that this appears to be 1, and 1 unit, the base of the triangle, 1 unit. But then I'm going to say the top, the rise is 4, and the run is 1. So at this point, right here, I have to have 4, because it's 4 over 1. 1, 2, I don't know, I don't have units, so I'm going to say 2, 4. Or 1, 2, 3, 4, I'm not sure. So at this point, I have to have 4. I'm going to choose another point.
I have a question.
Yes?
Would that be -4?
No, because the slope is positive.
Oh, okay.
But yes, here it will be negative. But since it's this, it's rise over run, so 4/1. The function is coming from -infinity, but the slope of the tangent line is positive because the function is increasing. If the function is increasing,
that makes sense.
The slope of the tangent is positive. If the function, we're going to talk about this in detail later on. So if the function is decreasing, the slope of the tangent line is negative. Perfect. So see, this is large, but now I'm going to choose another point, and I'm going to choose a point here. I will draw the tangent line at that point. I will choose 2 points anywhere, it doesn't matter. So I'm going to choose this point, let's say in this point on the tangent, and I'm going to form a right triangle. To determine the slope of this tangent now, and I'm going to say, I think that if this is 1, this is 3. So then at this point, I have 3.
I have a question.
Yes.
So you're just like picking points. Is that something like we would just pick points that we want, or would it specifically say use points like when X
No,
is?
you don't have any points. You have to estimate. You have to choose points. See, I chose 2 points here because one of them has a high slope, the other one has a smaller slope, and the next one will have a smaller slope, and the next still positive, and the next one will have a smaller slope, and the next one will have a smaller slope till 0.
So if we're asked to estimate and we just choose the points like you're choosing, how is there like a number of points that we should have?
No, there is no specific number of points, but you have to say, okay, obviously, if I continue here somewhere, this is huge. The slope is, so what I'm graphing here a vertical line, which is incorrect. But what I'm saying is, obviously, the function is coming from, so the derivative is high, slower, smaller, 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 smaller to 0.
Okay. Thank you.
Thank you. On this side, obviously, it's going to be negative because the slope of the tangent line at these points will be negative. So I'm going to choose this, draw the tangent line, and find 2 points. And I'm going to say these 2 points. And for me, on my graph, I see they're equal. So 3/3, 2/2, 1/1, it doesn't matter. So at this point, it will be -1. And then it will become still negative, right? But closer and closer, closer and closer to 0. So here's my graph. So between the maximum and the minimum, the rate of change is negative because the slope of the tangent line is negative. I specifically use this point because, as you see, at this point, so here's what happens. So this is 0, and this is negative, not too big, negative, bigger, negative, bigger, the highest negative, but then still negative, but smaller, and then smaller, and then smaller, and it gets to 0. On the other, yes?
I'm looking at the F prime one. It kind of looks like it's going to be like, if I'm just going to estimate what the function is, it's like it kind of looks like negative x to the power 3, and the
Yes,
one above looks
yes,
like
because this
negative
looks
x to
like
the power
x to the
4.
fourth. Yes, this looks like x to the fourth, and this will be, of course, x to the third, if that's the case. So, quote unquote. Exactly. So, again, it's positive, so it's 0 here, and then positive, big positive, but then approaches 0. So, again, big positive, but then approaches 0, and then it will become negative, bigger and bigger and bigger and bigger and bigger and bigger. So that's the rough graph for f prime. Again, what does this say? It says that the slope is positive, but it gets closer and closer to 0. The slope becomes negative, large negative, so to speak, and then smaller and smaller and gets closer and closer to 0. And then the slope again is positive, and then 0, and then closer and closer to 0. And then the maximum, I meant to say, and then it's 0, gets closer to 0, and then becomes negative. So that's the interpretation of the derivative. Any questions? So I'm going to have this as page 9. Okay. The other thing I was just going to mention is to go back. We'll have more examples. I want to go back now to 2.7. Because 2.7 are specific cases of 2.8, of the derivative function. So what is the difference between f of x, well, let's say f prime of x, it doesn't matter, and f prime of a? What is the difference between these two? What does this represent and what does this represent? We know what this represents. We just calculated for 6 functions, 4, 5, 6 functions, right? What is this? How do we call it?
That's f of x plus h.
The limit.
Or
yes.
The limit, yeah.
Yes,
The limit
but what? How do we call it? Yes, the limit of f of x plus a mentioned f of x over h. But how do we call this again? The
differential
derivative
yeah.
function. The terminology is like a foreign language. We have to review it. We have to review it and talk about it. What do you think this is? If f prime of x means the derivative function, what does this f prime of a mean?
Is that similar to evaluating?
Exactly. So the value, of course. Very good. Thank you very much. The value of f prime of x when what?
x approaches a.
Oh, when x is a. This is a function. So the value of f prime of x when x is a. That's exactly it. For this one, we have only one definition, and we practice it. The limit of f of x of the difference quotient. This one has 2 definitions. You can say, why 2 here and 1 here? To be exact, if you don't want to use these, use this, and then plug in a, and you get the answer. If it's not a, it may be 5, plug in 5. If it's -3, plug in -3. But this is a good practice, okay? Find f prime of a, but there are 2 definitions. Okay, so let me show both definitions, and then we'll work on more functions we're using those definitions. So this will be 10, because 9 will be the graph. So I'm going to write them again. So f prime of x and f prime of a. And I'm going to put all definitions together. So this one, I'm not going to ask you because I tortured you enough with this. So limit as age approaches 0 from f of x plus age minus f of x divided by age. And here there are two definitions. One that is identical. Just replace x by a. So f prime of a equals the limit as age approaches 0 from f of a plus age minus f of a divided by age. So there is no difference here. It's the same thing. Just from the very beginning, replace x by a. There is one more. There is another definition, which is f prime of a. And this is the limit when x approaches a from f of x minus f of a divided by x minus a. It's still the same definition of the slope of the secant line. Same thing. So these two are identical. Just replace x by a. And this one is helpful because some functions will be easier to work with this definition for f prime of a and this definition for other functions, f prime of a. To be honest, this you can forget about if you don't want to. I think they're useful. And use just this, and then at the end, replace x by a, and you're done. But let's practice these. So Amanda, if you want to share, we are going back to page, I'll find it. So we are now on page 150, if you'd like to open, on page 150. Between 23 and 26, let's choose one. 23 and 26 on 150. And then we'll move away from that and we will determine other things. Oh, I forgot about this. I'm going to do this too. So if anyone can choose a problem, if not, I will choose. So between 23 and 26. And this is problem 17.
24.
Okay, which one? 24 you said?
Yeah.
Okay, perfect. Not a friendly function, but that's okay. So f of t equals t to the third minus 3t. Perfect. Okay, so what I recommend, since we've been using this like a lot so far, let's try this one now. So we're going to write f prime of a equals limit. Since it's t, I cannot use x, so it's t approaches a from f of t minus f of a divided by t minus a. So we want to use a second definition because this is exactly the same. Okay, perfect. So therefore, I will continue replacing f of t. Limit as t approaches a. F of t is t to the third minus 3t. Careful now. F of a with minus in front. Let's write it first. So a to the third minus 3a divided by t minus a. Actually, you may like this definition more than the previous one with age approaches 0. I don't know. Maybe, maybe not. Okay, perfect. Let me see. Oh,